In this section of the notes, we will discuss how to go between linear and angular quantities. In a math course, you may have learned the relationship S equals R theta, where S is the arc length, R is the radius of the circle, and theta is the angle. Because we're talking about objects in motion, though, we're going to talk about the change in arc length times the radius of the circle times the change in the angle. And our goal here is to be able to go between angular velocity and linear velocity, and angular acceleration and linear acceleration. So I'm going to take this relationship I just wrote down and divide by the change in time. So a change in displacement with respect to time is velocity, and the change with angular displacement with respect to time is angular velocity. Now this t here stands for tangent, so we're going to talk about the tangential velocity, so it's the velocity the object has that's tangent to the circle at that particular moment. For our purposes, linear and tangential will be exactly the same thing. There are differences, but not with the way we're setting up our problems. I can take this one step further and talk about the change in velocity with respect to time and the change in angular velocity with respect to time. So this becomes tangential acceleration and angular acceleration. So notice here that there's this radial component, so the radius matters. And this is why we talk about angular quantities rather than linear quantities, because there is a difference between the linear or tangential velocity here and here because the change in arc length is different. So the velocity for the smaller circle is going to be smaller, and the velocity for the larger arc length is going to be larger because it increases with r. And that's because the particles here have to travel less distance, so they don't have to travel as fast to keep up with the particles that make up the outer portion of the object. This way they rotate as one. If they all had the same linear velocity, this portion would outrun the outer portion, and you would end up with what we call differential rotation, where the inner parts rotate more often than the outer parts, which cannot happen with rigid bodies. We're not going to talk about the case where this can rotate at a different rate than this. So this means that this velocity has to be different than this velocity. But because they're still sweeping out the same angle, we can talk about a singular angular velocity or a singular angular acceleration.